Your attention, please.
How do you hear sounds? Chirping of birds, the voice of people around, the ringing of a bell, announcement from speakers, etc. How does sound travel and reach your ears? Sound is caused by vibrations and travels through matter in the form of waves. Have you ever heard a flute playing? Can you guess what vibrates here? It's the air column. The vibrating air column produces the soothing music from the flute. If there is no air, the sound would not have reached the ear and we will not hear any sound. Thus, sound requires a medium for its propagation. Strikes a hammer against a nail. The sound of the blow is heard a little while after the actual impact. Or when a metal is cut using a bandsaw, the sound is heard some time after the sparks are seen. These two examples indicate that sound travels through a medium with finite speed. However, the speed of sound varies from medium to medium. The speed of sound is more in solids, less in liquids, and the least in gases. Let us look at an experiment conducted by Sanjay and Rohit to prove this. Sanjay yells from his end of the tunnel and clangs on a pipe inside the tunnel at the same time. To find out which sound Rohit heard first, click the play button. At Rohit's end, the clanging sound is heard before the yelling sound. This is because sound travels faster through the pipe than through the air. In other words, sound travels faster through solids than through liquids and gases. The speed of sound in a medium is affected by two factors: elasticity and density of the medium. This relationship is described by the given formula. According to Newton, there is no change in the temperature of a gas when sound travels through it. In other words, it is an isothermal change. Hence, isothermal elasticity, which is equal to the pressure P, should be used in the formula. However, the speed of sound calculated using this formula was lower than the experimental value. Laplace realized that the propagation of sound is an adiabatic change since there is no loss of heat in the medium. Thus, the modulus of elasticity for an adiabatic change should be used in the formula. This modified formula gave the correct value of the speed of sound. The speed of sound is higher in solids because they are much more elastic than liquids and gases. This is depicted in the given table. Let's summarize what we have learned so far in this animation. During thunderstorms, we see lightning first and then hear the sound of thunder. Do you know why this is so? This is because the speed of sound is less compared to the speed of light. Unlike light, sound requires a medium to propagate. It propagates as a disturbance through the medium. The speed at which sound travels depends on the elasticity and density of the medium. Sound travels fastest in solids and slowest in gases. The speed of sound in gases is given by the equation as shown. Where v is the velocity of sound, Gamma is the ratio of the specific heat at constant pressure to the specific heat at constant volume. P is the pressure of the gas and rho is the density of the gas. There are several factors that affect the speed of sound in gas. They are density, temperature, humidity, and wind. Click each factor to learn more. One of the important properties of a gas is its density. From the equation of the speed of sound, it is evident that the speed of density is inversely proportional to the square root of the density. So, sound travels with faster speed in gases with less density than gases with high density. Temperature is another factor that affects the speed of sound in a gas. The speed of sound in gas increases as the temperature of the gas rises. This is because a rise in temperature reduces the density of the gas, thereby increasing the speed of sound. So, sound moves faster in warm air than in cool air. In fact, the velocity of sound is directly proportional to the square root of absolute temperature of the medium. Humidity is the amount of water vapor or moisture contained in the air, which is a mixture of gas. The speed of sound increases with the increase in humidity. This is because the presence of moisture decreases in the density of air. So, sound moves faster in humid air than in dry air. The speed of sound varies with the direction of wind flow. If the direction of wind is along the direction of propagation of sound waves, then the speed of sound increases. If it is in the opposite direction, then it decreases.
Select the length of the string and click pluck gently or pluck strongly to hear the sound and see the wave shape.